Okay, so we will continue with the problem on Fourier transform. So question that I have given you as assignment, it was find the Fourier transform of this signal, right? E raised power
Yes.
at u of minus t, right? This was a signal whose Fourier transform you have to find. So I will not show the solution. I will just write down f of t, that's time domain signal shown in this graph. It's will be f of omega Fourier transform, and f of omega here, it will be equal to e. Sorry, wait a minute. It will be equal to 1 divided by a minus j omega. So its answer will be this. Now from f of omega, you can find its magnitude spectrum as well as its phase spectrum. And obviously this is a real signal. Its magnitude spectrum will be even and its phase spectrum will be odd, as already
Odd.
discussed.
Yes, sir.
Right. Now before going for the function signum of t, I will write one more signal whose Fourier transform you have to find. Since I already yesterday I mentioned that signum of t is its Fourier transform is limited defined, because area under the curve of that very function or signal is infinity. When area under that curve is infinity, so you cannot have the mathematical definition. You cannot apply the mathematical definition of Fourier transform. So you have to go by some indirect means, and that is limited defined Fourier transform. We will see that very thing. So you just try to find the Fourier transform of this signal. This is your e raised power minus at u of t. This portion will be your e raised power at u of minus t. This whole signal is your f of t. F or f1 of t, you can consider this. Can I say this signal is nothing but f1 of t is already defined above, f of t plus f of minus t.
Yes, sir.
Can I say? And f of t is this signal,
U of t.
e raised power at minus at u of t, this signal. And you just reverse this, means reversal, and then adding these two. Reversal means this will be e raised power. Reversal means this is your
Minus.
e raised power at, minus and minus is plus, so this is u of minus t. Then adding these two signals, you will get resultant like this. So this is your f of t signal. And already f of t, its Fourier transform, you have already defined, that's 1 divided by a plus j omega, right?
Yes, sir.
Okay, so what about this? It's, you have also already find that this is a minus j omega, simply using the time reversal property. And there is minus here, and you can have minus omega here. So this is by the property of time reversal, and you have already done this question, which was your assignment, right?
Yes, sir.
Okay, so you just add these two. Adding using the linearity property, you can add these two. So you will have f of t plus f of minus t. Its Fourier transform is just the addition of these two signals. That's a plus j omega plus 1 divided by a minus j omega, right?
Yes, sir.
Okay, so then this will be equal to a square minus j
J
omega
omega
whole, that will be j omega whole square. Well done. Then this will be a minus j omega plus a plus j omega and minus this will cancel out, so your resultant will be equal to twice a square. J square is equal to minus 1 because j
Yes,
square is
sir.
equal to minus 1. Minus and minus is plus, so you have this. So this is your signal, this f of t plus f of minus t. Its Fourier transform is equal to this, right?
Yes, sir.
Okay. So we can conclude few things from here. Can anybody tell me this signal, above mentioned signal as shown in the graph, this graph, is this signal even or odd? Is this even or odd? Tell me from the graph, what can you conclude? Is this symmetric about the origin? Yes,
Sir, it's even.
it's even signal because this is symmetric about the origin. Right hand side, this right hand side and left hand side, they are almost equal. You can say this is symmetric about origin because they are similar in shape. So this is an even, or you can use the formula f of 1 of t is equal to f1 of minus t. They are both equal, so this is an even signal. So for an even signal, spectrum, that means amplitude spectrum, will be always this real. It will not be having any imaginary component. So we can conclude one point here, that is, from this you can conclude that Fourier transform of a real and even signal, real and even, this in case of time domain, even signal is purely real and even, is purely real and even, because this is also even function. If you will see, you can consider this equal to f1 of omega, then you can have f1 of omega is equal to f1 of minus omega. So this is an even function of omega. So you conclude that Fourier transform of a real and even signal is purely real and even.
Even.
Similarly, for the signal, similarly for another signal, this this is your e raised power at minus at u of t. This is your e raised power minus e raised power at and u of minus t, right? Hello, are you getting me?
Yes,
Okay.
yes, sir.
So you can consider this as your f of t. This is your f of minus t and minus of f of t. Because if somebody having confusion, f of t was your this signal, this your f of
Yes,
t. F of t is equal to e raised power minus at u of t, u of t. Okay, u of t. Then if you will just reverse this, reverse time reverse, this will be your f of minus t. This is your e raised power at u of minus t, because you will just replace t by minus t. So this is your function. Now there will be amplitude reversal. Amplitude reversal will be, this will be minus f of minus t. Minus t is just time reversal. Then minus f of minus t is amplitude reversal. So you will get this. This will be your e minus e raised power at u of minus t. Okay. Okay.
Yes, sir.
Okay, so you are this signal which I will represent by f of 2t. This f of 2t is nothing, it's equal to f of t minus f of minus t.
Minus
F of t minus f of minus t. So this is your signal. Now, can we are already done with the f of t Fourier transform f of t. What's the Fourier transform of f of t? So f of t minus f of minus t. It's, tell me, Fourier transform of f of t is what?
1 by a
1
plus j omega.
1 by a plus j omega. Well done. Then there will be minus 1 divided by a
A
minus j.
minus j
Very
omega.
well done. So this is your signal. This minus is here. Okay. So then this will be equal to a minus j omega minus a minus j omega. Then it will be a square plus omega square. Then a and a cancels out. It will be equal to minus 2ij omega divided by
A square
a
plus
square plus omega square, right?
sir.
So this is the value of f of t and f of minus t. So ultimately you get f of t, f of 2t, its Fourier transform, that's f of 2t is equal to this. F of t minus f of minus t, its Fourier transform will be equal to f2 of omega, and that is equal to minus 2ij omega divided by a square plus omega square. So first of all, tell me f of f2 of t, is this even signal or odd signal? Is this even signal or odd signal? This is an odd signal
Odd, sir.
because this is not symmetric about origin, right? So this is an
Yes, sir.
odd signal. And what about this? This is also odd and imaginary. So you can conclude this is in general case. So any signal you having any any signal in time domain that will be odd, its Fourier transform will be always purely imaginary and odd. So Fourier transform of a real and odd signal. Obviously, it is in time domain. Odd signal is purely imaginary and odd in nature. Odd in nature. Done?
Yes,
Okay. Now coming to our question, that is signum of t. Can I say here? Question was signum of t. Find its Fourier transform. The signal was like this. For the positive half cycle, it's equal to 1. For the negative, it's
minus 1.
equal to minus 1. Well done. And this tends towards infinity, continuing. It's like u of t. Look, if somebody will tell me its area, mod of this area under the curve, that is integration, you will say obviously this is infinity. Sorry, this is not zero, this infinity, because area under this curve it's continuous going towards infinity, and its area, and this it will come like this signal. Area under this curve, it will be always equal to infinity. So in actual terms, you can say this is not properly defined signal because area under the curve is equal to infinity. So you cannot directly apply the formula, mathematical formula. What was that? Minus infinity to infinity f of t e raised power minus j omega t dt. You cannot use this formula directly to calculate its Fourier transform. So there should be some indirect means to define it. Actually, this is a power signal. So for power signals, there are some indirect means to calculate its Fourier transform. And what is that? We will try to understand. Uh, already defined f of f2 of t. What was that? अभी किया ना हमने. We're done with this question.
Sir, E of
Like
A.
this. Okay. So it is E of minus AT U of t. Well done. And this is your E, then AT U of minus t, and this is minus this your t. And this is equal to f of f2 of t, right? And f2 of t is equal to f of t minus f of minus t, right?
Yes, sir.
Now, if I will tell you that limit of f2 of t such that a tends towards 0 is nothing but your signum of t, what you will say? I will say if this a value here and a value here, it will tend towards 0, and then this this graph, it will tend towards like this signum of t minus 1 1 t signum of t, right?
Yes.
Okay, so you can say why, because I will try to show this. Look, if a tends towards 0, what will happen? This will be e raised power 0 minus 0 into t u of t. E raised power 0 is 1. So this will be equal to 1 into u of t, and this portion will be your u of t. Similarly, this will be minus u of t. So this is nothing but your signum of t. So you can conclude from here that if you will put limit of a tends to 0 in case of f2 of t, then this will be equal to signum of t, right?
Yes, sir.
Now you can say Fourier transform of this limit of a tends to 0 is equal to Fourier transform of signum of t, because we aren't using the mathematical formula, we are using indirect means. And a reason I have mentioned already was the reason for the same. So you can conclude, because you need Fourier transform of signum of t, right? You can say
Yes,
this is
sir.
equal to limit of a tends to 0 Fourier transform of f2 of t. And Fourier transform of f2 of t, that is this signal,
Mine.
I have already mentioned this, is Fourier transform is equal to minus 2j omega divided by a square plus omega square, right?
Yes.
Okay, so it's Fourier transform limit of e tends to 0. Tell me the Fourier transform value. Minus 2j omega
Yeah.
divided by a square plus
Square plus
omega
omega
square.
square.
Now put wherever you have a, put that equal to 0. You will get the value limit of a tends towards 0. Put the value simply minus 2j
Minus 2.
omega 0 square plus omega square, and that is equal to minus 2j omega divided by omega square. Omega and omega cancels out. You have value minus 2j by omega, right?
Yes.
Now, if you will rationalize this simply, 2j into j divided by j omega into j, you will get minus 2j
Omega
square
square.
divided by j omega. J square is minus 1, minus and minus is plus, so you have 2 divided by j omega. That is your answer, right? So this
Yes,
is the exact way you have calculate all these limited defined for the transform signals. Getting? And most of
Yeah.
them will be power signals. That means power signals will be limited defined. Power signals will have limited defined Fourier transform, and so you cannot use the mathematical definition directly. So you have to find some indirect means to calculate it, right? Okay,
Yes.
please tell me, anybody having any question?
No, sir.
Anybody else?
No, sir.
Okay,
No, sir.
okay. So one more question. Uh, then we will wind up this and go for the characteristics media channel key characteristics, and then we will go for this maybe sampling term. Find the Fourier transform of f of t, and f of t is your impulse signal, delta t signal, and this is a fundamental signal. Can anybody draw the graph of the delta of t? This will be your delta of t, and its area under the curve will be always equal to 1, right? Area under delta of t, that's area under this curve, will be equal to 1. So this is your delta of t. You have to find its Fourier transform. And by definition, because area under this curve is not infinity, so you can use the mathematical definition, and that is f of omega is equal to minus infinity to infinity f of t e raised power minus j omega t dt. And this is equal to minus infinity to infinity f of t. You will replace by delta of t, because here f of t is delta of t, j omega t dt. And now I told you already, then whenever delta t is multiplied by any signal, that's this delta t into x of t, this will be always equal to delta t, and this t equal to 0. You put that here, it will be equal into x of 0. I told you this property.
Yes, sir.
Okay, so using the same property here, what you will get, minus infinity to infinity delta of t into e raised power minus j omega t will be 0. You will get 0 dt. And e raised power 0 is equal to what? E raised
1.
power 0 is 1, right?
Yes.
So delta t into 1 dt. And this value will be equal to 1, because area under the delta of t by the property of this impulse function is equal to 1. So you conclude that f of omega is equal to 1.
Yes.
So you will say delta of t, its Fourier transform is equal to 1. Can anybody draw the graph of this means magnitude spectrum? First of all, we will see delta of t is this. Is this delta of t even signal or odd signal? Even signal. Because this symmetric about origin, delta of t will be equal to delta of minus t.
Yes.
Even signal. So even signal, its Fourier transform will be purely real and even. And what is that? That is, this is omega magnitude of f of omega, and it's equal to 1. Typically, you can conclude that obviously this is even or real and even. You can say purely real and even. Now I will tell you one thing, that is that delta of t that's present in the time domain at origin only, it contains all the frequency components. Means delta of t, it will contain all the frequency components from 0 to infinity. Look, because its value is always equal to 1 everywhere. It's independent of omega, so it will be contain value 1 everywhere. That's it. So you can say that this contains all the frequency component. That you cannot conclude in the time domain. Look, from the time domain, you cannot say delta of t, it contains which frequency. You cannot get the information. But once you convert this to frequency domain, you can say that it contains all the frequency components. What about phase? Because you can say this is equal to J0. Tell me, phi, only 10 minutes left. Okay, then this phi will be equal to tan inverse of b. B is 0, 0 by 1. That's tan inverse of 0 is equal to 0. So its phase value will be 0. That means it will not contain any phase value. It's 0, like this. Got it?
Yes.
So you can say delta of t is having all the frequency component from 0 to infinity. And all these frequency component will have a uniform value that's equal to 1. Okay,
Yes.
okay, this is your assignment question. You can do this at home before going for the characteristics of media channel. Find the inverse Fourier transform of delta of omega. By using the mathematical definition, you get tell me. Find the inverse Fourier transform of delta of omega. This is your question. And second one is find the inverse IFT of delta of omega minus omega naught. These two questions you do.
Yes.
Okay. Okay, anybody having any question? Okay, thank you then. I will